Greetings, scholars. Mr. S here, beginning to take a look at piecewise functions. I want us to consider something as basic and simple as a puzzle as we look at piecewise functions. Piecewise functions are really very simple. It's like we take the pieces of different functions and put them together, much like a puzzle. We've got all these different pieces. All we have to do is snap them together to create a whole new image. As with piecewise functions, we'll be creating a whole new function by putting these different pieces together. So, through the magic of editing, let's take a look at what these piecewise functions will look like. We're going to take a look at several problems using piecewise functions. The first thing I would like us to do is go ahead and take a look at an absolute value function that you should have seen before, and start off with just simply graphing it. So if we look at this, the simplest way to graph this is using the transformations. So remember that inside talks about going left or right. Inside it's opposite, so when we go -1, we will end up over here. We also have a transformation at the end, up or down, going in the direction it does say. The sign is correct in this case. So we go up 1, 2, 3 spaces. And that's our vertex, our turning point. Now since there is no stretch or compression, our slope is simply 1. So we go up 1 over 1, or up 1 over 1 to the other direction. We could have also simply plugged in these x values of 0, -1, and -2 and got the same points. But now we will graph this absolute value. Now, why I said before in the notes of this lesson that you've actually seen these piecewise functions is because this is now two pieces of functions put together into one. So we can actually see these are two linear functions that are put together to make one absolute value function. That is what makes them piecewise functions. So after we've graphed this, another thing I would like us to do is now write this as a piecewise function. Since there are two linear functions that make up this absolute value, we'll have two functions that we write. So we're going to look over here. We're going to write this function first. Now, we already know the slope is a -1, so that's a -x. We do need to know what the y-intercept is, though, but a simple use of our slope can tell us what that is. Going down 1 and over 1 will tell us that our intercept is actually at 1, 2. So that is our first function. Our second function, we now need to look at this one, is slope of 1 again. This one we can already see what the y-intercept is, so it's 1, 2, 3, 4. And I've kind of written a little too close, but we also need to write what x values we're going to use for these functions. So we can see that the x values from this direction is what we use for the first function, and the x values in this direction is what we use for the second function. So when we look at this, this starts at -1. So any values of x that is less than or equal to -1, we're going to use that first function. The other function we're going to use for x is greater than -1. And that's how we would write the piecewise function. Now, if we are actually given something like this, we don't even necessarily have to take the step of actually truly graphing it. In this first one, we really kind of needed that step so we could really see what the two functions would be. But if we look at this, we can see the only thing we have is a vertical translation going down 1 unit. We do also notice that we have a negative reflection. So just a quick little sketch, we don't really even need to have to actually graph it. All this did was go down 1 space and open down. Our 2 is going to be our slope. So if we're going to write this as a piecewise function, Absolute values have two pieces, two linear functions. We can write our negative. Oh, actually, is that negative? We look at this, it's actually going up. In this case, since it's reflection, this first function is actually positive. And our y-intercept is -1. Our second function, that's where actually the negative goes. So this is going down, so that's negative 2x. Again, -1 is the y-intercept. So again, we still need our 4. Which x values? Here, our breaking point is actually the 0. So x is for x less than or equal to 0, and for x greater than 0. Now, a final type of problem on this board that I would like us to do is taking a look at taking the absolute value written as a piecewise function and turning it back into an absolute value. So let's take a look at the graph of this. This is two fairly simple linear equations. A y-intercept of 3, 1, 2, 3, and a slope of -1, over 1, down 1, over 1, down 1, and over 1, down 1. Then my other linear equation, y-intercept of -3, now a +1 is a slope, over 1, over 1, over 1, over 1, over 1, over 1. Oops. That would be right there too. And there's my two linear equations. But looking at where the breaking value is, it's at 3. So I can just take that part off and that part off. And so here's my absolute value graph. So let's write this as one single absolute value. Absolute value of x, and you can see where our vertex moved, over 3 spaces to the right. Now remembering it's it's opposite inside, so even though it's +3, it's -3 inside. And we can see we didn't go anywhere up or down. So here is my single absolute value function. So a quick change of the board, and we'll do one more problem. And like magic, here's our new problem. This final problem, I'm actually going to point out several different things that a piecewise function problem can ask you. Now, if we look at this piecewise function, we'll notice it's made up of an x squared and an x plus 3, a quadratic and a linear function. As our activity said, we're not always going to be dealing just with linear functions. We have quadratics, we have linear, we have rational, square root, radical, cubic, etc., etc. So here, let's go ahead and graph this first. Now, I've made these relatively simple, so we can just look at the parent functions, transformations, and things like that. So we've just got the parent function x squared of a quadratic. So it's going to have its vertex here. Now, I could go ahead and draw the whole thing, but look where I want it. I only want it to the left of the 0. So I'm actually only going to draw this part of the graph. Notice 0 is included. So I'm going to make this a nice filled-in circle because 0 is included in this graph. Now let's look at the other one. X plus 3. Y-intercept of 3. 1, 2, 3. Now notice the 0 is not included here. So I'm going to do an open circle. That part's not included. And a slope of 1. Over 1, up 1. Over 1, up 1. And this is my graph. Another thing a problem might ask you is the idea of points of discontinuity. You will notice there is a break here. That's called a point of discontinuity versus the absolute value ones. They met at the two functions. That is a point of continuity. There's no break in the graph. So here, this is a break in the graph, so there's actually a point of discontinuity at the value of x equals 0. One function would have one value for it, the other function would have another value for it. We could see that would happen if we plugged in 0 for both of these functions, that breaking point of 0. So when we plug in 0 for x squared, that's 0. But if we plug in 0 for x, that's 3. So we didn't even have to graph it to see that that was going to be a point of discontinuity. All we have to do is use that x breaking value in both functions and see if it's the same value or not. If it's different, it's discontinuity. If it's not, it's going to connect. And then two more things that we need to be able to look at this is the idea of domains and ranges. Looking at this graph, we want to ask ourselves, is there any values x can't be? There's not. This is going to go off there, it's going to go to infinity. So the domain is all real numbers. But when we look at the range, the y values, we can see that there's nothing negative. So your y values are going to be greater than or equal to 0. And then the final thing we should be able to do with these piecewise functions is evaluate them. So if I want to evaluate the function, say at -1, I need to look at my criteria for which function I'm going to plug into. -1 is less than 0, so I'm going to use this first function of -1 squared, which is +1. If I want something to plug in here, it's going to have to be bigger than 0. So for instance, let's say 2. 2 plus 3, which is 5. The only tricky part is if I plug in 0. Where am I supposed to plug it in? 0 is not included here. 0 is included here. So I should plug it into the first function. And that's how you would evaluate a piecewise function. So go ahead and continue through the lesson, and good luck on applying these piecewise functions.